Today we will discuss one of the practicals, that is potentiometer E1 by E2. So with the help of this experiment we can compare the EMFs of two given cells by using this potentiometer with the help of individual or separate method. That means the two cells will be connected in the circuit one by one, that is at a time only one cell will be connected in the circuit, and that's why it is individual or separate method. That means if E1 is the EMF of one cell and E2 is the EMF of the another cell, then we can compare the EMFs as E1 by E2. So for that purpose the materials needed are the potentiometer. So this is the wooden board. On this wooden board a conducting wire is stretched in the form of number of segments. Each segment will be having its length equal to 1 meter, that is 100 centimeter. So for practical purpose this wire will be stretched on this wooden board in the form of 4 segments, 1, 2, 3 and 4 segments. Each segment will be having its length equal to 100 centimeter. Then the length of the wire will be measured in such a way that if the null point is obtained on the first wire, then its length will be measured from left to right. If null point is obtained on the second wire, its length will be equal to this 100 plus length of the second wire from right to left. Then if the null point is obtained on the third wire, then this 200 plus the length of the wire 3 measured from left to right. Similarly, if the null point is obtained on the fourth wire, then 300 plus length of the fourth wire measured from right to left with the help of this meter scale. So for these 4 wires the readings or the lengths will be measured either from left to right or from right to left, and therefore the meter scale attached to this board is also marked from starting from 0 to 100 from left to right, and again from 0 to 100 from right to left. So in this way the length of the wire will be measured during the finding out that null point, and therefore this will be the potentiometer. Then there are 2 free ends of the wire which will be connected with the help of these copper strips to 2 terminals. Let this terminal be P, that is the first free end of that wire, that is taken as P. Second will be taken as Q. Now from this point P it will be connected, this point P will be connected to positive terminal of this driving cell or battery. So this P terminal will be connected to positive terminal of this battery. Then negative terminal of this battery will be connected to one of the fixed terminals of this rheostat. So this is the rheostat. Then variable terminal of this rheostat will be now connected to terminal Q of the wire. So this Q terminal of the wire will be connected to this variable terminal of this rheostat. So with the help of this rheostat we can slide this with the help of this slider along the length of this rheostat, so that the current in the circuit will be controlled. Now again from this point P another wire will be connected. This is the another wire which will be connected to this terminal P, to which the positive terminal of the cell will be connected. So to this end the positive terminal of the cell whose EMF which we have to measure will be connected. So positive terminal. Then negative terminal will be connected to another end of the wire, and then this wire will be connected next to a sensitive galvanometer G. So between the wires or between the 2 terminals, that is terminal P of this wire and one of the terminals of the galvanometer, that cell will be connected. Then other end of this, that is second terminal of this galvanometer, will be connected to a metallic rod. So here there will be a metallic rod. So second terminal of this galvanometer is connected to this metallic rod, which is called as the jockey. It will be used for proper electrical contact with the potentiometer wire. And so this is the jockey. It will be connected to second terminal of this galvanometer. So if you consider this circuit diagram, then all that connection will be shown. 1, 2, 3, 4 will represent the 4 segments of the potentiometer wire, each of length equal to 100 centimeter. Then P and Q are the 2 free ends of that potentiometer wire. In between these 2 points P and Q, a series combination of battery, that is driving cell, key and rheostat will be connected. In this experiment, the direct battery will be connected to rheostat. Our hand will act as this key, or direct connection will be made. Then again from this terminal P of the potentiometer wire, 2 wires will be connected there, which will be connected further to cells E1 and E2. So to terminal P, positive terminal of the cells will be connected. Negative terminals are connected next to the galvanometer. Here one line is continuous line, another line is dotted line. It represents that at a time only one cell will be connected in the circuit. Then this wire will be connected to one of the terminals of galvanometer, and then second terminal of the galvanometer will be connected to jockey. Again there are 2 positions shown on this 4th segment of the wire, that is J and J dash. This will be suppose for cell E1, then this will represent for cell E2. Now as per circuit diagram, if all the components are connected, then what is the formula for this? So formula is equal to comparison of EMFs, that is E1 by E2 equal to L1 by L2. E1 by E2 equal to L1 by L2. Then if you consider observation table, it will contain columns as observation number 1, 2, 3, 4, 5. So 5 readings we will have to take in this experiment. Then when the null point is obtained for cell E1, then length L1 will be measured in terms of centimeter. Then third column will be for cell E2. When the balancing point is obtained, at that time length L2 will be measured in terms of centimeter. And then finally we can find out E1 by E2 as the ratio of L1 by L2. So like this for all the 5 readings, E1 by E2 will be calculated in terms of L1 by L2, and at last mean of E1 by E2 for all these 5 readings will be calculated, and that mean value of E1 by E2 will be written in the result. Now from this formula, as it is E1 by E2 equal to L1 by L2, by taking the readings for the balancing points or the null points, we can find out E1 by E2. But from the same formula we can calculate the EMF of one of the cells if the EMF of other cell is given. That means for example we have to calculate E1, E2 is given, so E1 will be equal to E2 into L1 by L2, so that will be E2 into mean of L1 by L2, mean L1 by L2 from this observation table. Now what is the procedure actually? As per circuit diagram, all the components will be connected. Then this driving cell, that is battery, will be made on. And now the precaution will be taken that the EMF of this battery must be always greater than the EMF of these individual cells, that is E1 and E2. But we know that for these cells the EMF is nearly equal to 1.5 volt for both these, and therefore greater than 1.5 volt, this potential must be set, and therefore the knob of this battery is kept on 4 volt. Now when this potential difference is applied between the two ends of this potentiometer wire, at that time the current will be flowing through this potentiometer wire, but no current will be flowing through the galvanometer, because when that jockey is touched to any one of the segments of the wire, and if the cell E1 or E2 is connected in the circuit, then and then only current will pass through this galvanometer, and that galvanometer will show some deflection. Now in the construction of the galvanometer, when no current flows through it, at that time its pointer will show 0 deflection, and when current is passing through it, at that time this reading will get changed. Some divisions will be now recorded with the help of this galvanometer. Now in this case, when all components are connected in the circuit, including E1 or E2 in the circuit, at that time the current is flowing through potentiometer wire as well as through the galvanometer. If the jockey is touched at any point to any segment of this wire, at that time this galvanometer will show deflection on one side. Suppose it is towards left side. Then when the jockey is touched to the first segment, the galvanometer shows deflection on left side. Then pick up that jockey and touch it to the fourth wire. At that time the galvanometer must show deflection on opposite side. Then and then only our connections will be proper. And therefore now let us see, we will connect that circuit. So first of all, cell E1, EMF E1 will be connected in the circuit, and so when it is connected in the circuit, now current will pass through this potentiometer wire as well as the galvanometer. Now at that time we will have to pick up that jockey now, and then we will have to first test it. So when this jockey is touched at any point on the first wire, the galvanometer must show deflection on one side. So now that galvanometer is showing deflection towards left of the 0. Now again pick up this jockey and touch it to the fourth wire. The galvanometer is showing deflection on right side. That means our circuit connection is proper. And now we have to find out the null point for this, and therefore now we have to touch this jockey at different points. That is, we have to tap this jockey at different points along the length of the wire, or we can slide that wire along the length of the wire, and therefore as it is slided, at that time there is no deflection. That is, deflection will not be equal to 0. But when this jockey is now slided along the length of this wire, at that time at a particular point we will get null point. That is, deflection shown by the galvanometer is equal to 0, and therefore we have to measure the length of the wire. So we have got the null point on the second wire, and therefore it will be 100 plus. Now the length of the second wire will be measured from right to left, and therefore it is equal to 59. So 159, that will be the balancing length for this first wire, and therefore 159 will be written in this first case. That is, in the first reading L1 will be written as 159. So if it is 159, if it is written like this, if it is 159 centimeter, then we will go for the next reading now. Now in place of E1, now this E2 will be connected, and by the same procedure we will get the null deflection, and therefore instead of now E1, that E2 will be now connected in the circuit. And now not necessary to check again, the connections. So directly we can now slide that jockey along the length of the wire, so that now that deflection is not equal to 0, but when that jockey is now slided along the length of the wire, at that time we will get so like this, it will give us 0 deflection. Now jockey is touched at this point, we will get 0 deflection, and therefore again we have got the null point on the second wire, and therefore 100 plus reading of the second wire, that is equal to 57, and therefore 157 that will be written as L2. Then by finding the ratio of these two, we will get E1 by E2. Now in the similar manner, we can proceed for second reading. So for second reading, for this second reading, again this E1 will be connected in the circuit, but at that time we will have to slide this rheostat. We have to adjust this rheostat slightly, so it will be slided now, and again pick up the jockey, touch it to the segment of that wire at any point, and then observe the reading in the galvanometer. So at that time it is observed that now the balancing length will get changed, that balancing length will get now changed. So suppose now it is slided along the length of the wire, suppose now null point we have obtained here. So if the null point is obtained on the third wire now, then 200 plus the length of the wire 3 from left to right, so it is 44 centimeter for third wire. So 200 plus 44, that will be our L1, that is the null point will be obtained at 244, so that it will be L1. Now this cell E1 will be now replaced by this cell E2, and again by the same procedure we can find out the null point. So in order to find that null point, now again the third wire we will slide that jockey, and therefore at this point suppose we are getting the null point. So at this point, if that null point is obtained, that is galvanometer shows 0 deflection, then again the length of the wire will be measured. Now it is 234. So 234, and therefore it will be written 234 in the second reading. Then again the ratio of these two will be calculated in the last column. So in this way, for all the 5 readings, by adjusting the rheostat, we can find out L1 and L2 the balancing lengths for all the null points shown for E1 and E2, and at last we can calculate E1 by E2, and finally the mean of that E1 and E2 will be calculated and it will be written in the result. So in this way we can perform this experiment of potentiometer for the comparison of the EMFs of two given cells.